have to find the integral of square root of sin 2x into cos 2x with respect to x. So by substitution method, we will solve this problem. Why substitution method? Because the integrand consists of both function and its derivative. So here we have two trigonometric functions, sin 2x and cos 2x. So if we differentiate sin 2x, you will get cos 2x, right? So both function and its derivative is the integrand. Now, which one to select as a function t? We have to select this original function and equate it to t. So let sin 2x is equal to t. Now we will differentiate this with respect to x. So this will be cos 2x and we have to differentiate 2x. So we will get 2, which is equal to dt by dx. So we have to make substitution for cos 2x dx, right? So we will cross multiply. So cos 2x dx is equal to dt by 2. So now we will substitute because all x is in the form of t now. So this will be square root of t and cos 2x dx dt by 2. So this implies 1 by 2 is written outside, integral of square root of t with respect to. So now this implies. So you might think, why did not we equate cos 2x equal to t? Because if we differentiate cos 2x also, we will get sin 2x and both of them are the integrand, right? So why we are not equating cos 2x equal to t? Because in the question we have square root of sin 2x and there we need to encounter with this dt and square root. So for this reason we are not writing cos 2x equal to t, we are just writing sin 2x equal to t. Now 1 by 2 to integral of square root of t is nothing but t to the power 1 by 2 with respect to t. So now this implies 1 by 2. So integral of t to the power 1 by 2 is t to the power 1 by 2 plus 1 divided by 1 by 2 plus 1. We have done the integration. We will write constant c. Now this implies 1 by 2 t to the power 3 by 2 divided by 3 by 2 plus constant of integration. Now this implies 1 by 2 into 1 divided by 3 by 2 into t to the power 3 by 2 plus c. So if you multiply these two, you will get back the previous step. Okay, we have just separated the terms. Now this implies 1 by 2. So this is a complex fraction. So when we have 1 divided by a by b, it will be equal to b by a. So we'll write this as 2 by 3 t to the power 3 by 2 plus c. Now this implies 2 by 2 is 1. So we are left with 1 by 3 t to the power 3 by 2 plus c. Now this implies 1 by 3, the value of t. So we have equated sin 2x equal to t, right, to the power 3 by 2 plus c. So therefore the conclusion is integral of square root of sin 2x into cos 2x with respect to x is equal to 1 by 3 sin 2x to the power 3 by 2 plus constant of integration. So this is the solution. Now 28th one, we have to find the integral of cos x divided by square root of 1 plus sin x with respect to x. So we know that if we differentiate sin x, we will get cos x, right? So both function and its derivative are the part of integrand. But if we also differentiate any constant plus sin x, this is also equal to cos x, right? So we can have any constant here. So this is constant. So still we will get cos x. So that is the reason we will take 1 plus sin x equal to t. If we differentiate with respect to x. So derivative of 1 plus sin x is cos x, and if we differentiate t, we'll get dt by dx. So we will write cos x dx is equal to dt, right? What if you have just equated sin x equal to t, not 1 plus sin x? Then you have to solve for square root of 1 plus t, right? So if that is the reason, we will take this 1 plus sin x, the entire denominator 1 plus sin x equal to t, so that we can solve the sum easily. Now this implies integral of, in the numerator it is t and in the denominator it is square root of t. So this implies integral of 1 by square root of t into dt. Now this implies integral of, so 1 by square root of t can also be written as t to the power minus 1 by 2 with respect to t. So we know that integral of x power n dx, when n not equal to minus 1, we can write x to the power n plus 1 divided by n plus 1 plus constant of integration. So this implies t to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus constant of integration. This implies t to the power 1 by 2 divided by 1 by 2 plus c. Now this implies, so with this step we can write it as 1 divided by 1 by 2, and this we can write square root of t plus c. So again we got this complex fraction, right? So 1 divided by a by b is equal to b by a. So this will be nothing but 2 by 1. So we can just write 2. Square root of t plus c. At the end we have to write what is the value of t. So t is nothing but 1 plus sin x plus c. So therefore integral of cos x divided by square root of 1 plus sin x with respect to x is equal to 2 into square root of 1 plus sin x plus c. So this is the solution. 29th one. Let us find the integral of cotx into log of sin x dx. So we have to equate one function as t, we have to differentiate, and this derivative must be there in the integrand, right? So if we differentiate only sin x, we will get cos x, right? But what if we differentiate the entire log of sin x? Let us do the substitution there. Let log of sin x equal to t. Now we will differentiate with respect to x. So if we differentiate log of x, so what is the derivative of log x? It is 1 by x, right? So we will get 1 by sin x. Now chain rule, we should also differentiate sin x, which is cos x, and this is equal to dt by x dx. Now this implies cos x by sin x is cotx. Now we will cross multiply dx, we will get dt. So now all x is in the form of t. So integral of, so log sin x can be written as t and cotx dx can be written as dt. So this implies integral of t with respect to t is nothing but t to the power 1 plus 1 divided by 1 plus 1 plus constant of integration. So this implies t square by 2 plus c. So what is the value of t? That is log sin x the whole square. So instead of divide by 2, I'll write 1 into 1 by 2 plus c. So therefore what is the final solution? Integral of cotx into log sin x with respect to x is equal to 1 by 2 into log of sin x the whole square plus c. So this is the required integral.